Good morning, students. Already we have done properties of determinant, which was really very important topic. Okay, and you need to practice a lot. Okay, similarly, another topic which is really important: inverse of a matrix, inverse of a square matrix. How to find? Already we have studied inverse of a matrix. How to find using elementary operations. You remember that we have done in chapter 3. Find the inverse of a matrix using elementary operations. Okay, there is another method using determinants, that is matrix method. Okay, and 6 mark question comes from this topic, inverse of a matrix. Okay, using determinants. Okay, for that we need to know adjoint of a matrix, and to know adjoint of a matrix we know new terms which are minors and cofactors. What are minors and cofactors? We need to know about these terms. Okay, so first I will be telling you what are minors. Okay, minors of a determinant. Suppose my matrix is given, yours, my determinant 3 cross 3 determinant is given, mine A11, A12, A13, A21, A22, A23. You know this is third row first column, third row second column. This is the element of third row, this is the determinant of 3 cross 3 square matrix. What are the minors? Minor of each element I can find out. Like A11, minor of A11 will be denoted as M11, and it will be by deleting first row, no? First row, first column. First row you delete and first column you delete. What determinant you get? That is your minor of element A11. Minor of element A11 is we can get by deleting first row and first column. So it will be what? Your A22, A23, A32, A33. This is your minor of element A11. Similarly, minor of all any element you can get. Suppose I want minor of element 22. Minor of element 22. So what it will be? Your by deleting second row and second column, because this is the element of second row, second column. So by deleting second row and second column, what determinant you are getting? A11, A13, A31, A33. This I got the minor of element 22. Similarly, any, like suppose you want minor of element 32. Minor of element 32 will be what you are getting, what your third row delete and second column. This is the element of third row, second column. By deleting third row and second column, you are going to get what? A11, A13, A21, A23. This is your what? Minor. Minor of any element you can get. Okay, this is the new term. Now this you need to know, because the important point is what are cofactors. Cofactors actually of any element in the determinant is denoted by Aij. This is known as cofactor of element Ij. It's equal to -1 sum the indices I plus j Mij. Means what determinant you got by minor of that one will be multiplied with the sign. Will be multiplied by the sign. So suppose I want to know this A11, cofactor of element 11, A11, cofactor of element A11. This is read as cofactor of element A11 will be what? Your -1. What is your 1 plus 1? Indices is 1 plus 1. Now minor of A11. Minor of A11 means by deleting first row, first column, what determinant you got, that it is yours. This one. What it will be? Your A22, A23, A32, A33. This is your cofactor of element A11. Similarly, I can get the cofactor of element A12. What it will be? Yours -1. What will be 1 to 1 plus 2? And what will be that determinant? By deleting what? That your first row and second column. So first row and this one A21, A21, A23, A31, and what is your A33? Got or not? That is yours. This. Okay, that is your by deleting what? Yours A12 by deleting first row and second column, A21, A23, A31, A33. Similarly, tell me what about A13? That is again -1, 1 plus 3, and by deleting which one? First row and third column. What is your first row and third column? So it will be what? Your A21, A22, A31, A32. Got or not? This will, from by this very interesting concept will come what that your, suppose I want to expand my, I want to evaluate the value of this determinant. How that I taught you in the first video, how we can get by through expanding row 1, expanding row 1. You get the determinant value. How you get this one, you know, first you take this element A11, you multiply with this 1, A1 plus 1, multiply A11, and by deleting first one, this one you are getting what that determinant A22, A23, A32, A33. Correct? Then next comes what that your plus minus 1, what that element 1 plus 2, and this first row second element is A12. By deleting first row and second column, what you are getting A21, A23, A31, A33. Similarly third will be minus 1, which element is there? 1 3, 1 plus 3, element is 1 3. By deleting first row third column, which determinant you are getting? A21, A22, A31, A32, that determinant you are getting. Now what interesting matter is coming, that I am taking out A11, what left? Nothing else but you left with cofactor of 1 1. Then again, if you are taking this element A12, you got the what that your cofactor of element 1 2, cofactor of element 1 2. Then it is 1 3. What you left with that? You left with the cofactor of element 1 3. So you are, if what you are getting, each row's element is multiplied, each element of that row multiplied by corresponding cofactor, you get the value of the determinant. You get what? Value of determinant. Okay, by this one. And but if any other element, suppose you are taking A11, but cofactor you are taking of second row first column, A12, but you are taking what that second row second column, and if you are taking this 1 3 element of first row but cofactor of second row third column, if you are getting, they are not same, so determinant value will come 0. This is very important. If any other you are taking this one, this will come. But if you are same, you are taking, suppose you are taking what that element of third row, this one, and corresponding cofactor third row second column, and same you are taking cofactor, and that is your third, and you are taking this one, this will give you nothing else but determinant A. Okay, so this is, you need to practice how you are going to find out minors and cofactors. By that, how you are going to get the determinants value, that you need to practice in the next exercise. Then I will be continuing with this adjoint of a matrix. Thank you.